Imagine a world where things can pop into existence seemingly out of nothing and disappear just as quickly. Imagine a world where you can be everywhere in the universe at the same time, and yet nobody can know precisely where you are. According to our best theory of nature, the standard model of particle physics, this is exactly how the world behaves, because at its heart lies the strange theory of quantum mechanics.
Quantum mechanics took away all the certainty that classical mechanics had put into nature. In the classical world, everything goes like clockwork. If you know where everything starts and how it's moving, you can predict where everything's going to end up. Quantum mechanics has this concept of uncertainty built in.
We can't know anything with absolute certainty. We can only work out probabilities of different outcomes happening. We have a very hazy view of matter because quantum mechanics tells us that matter doesn't just consist of particles. Particles can also behave as waves. And it's a very confusing and non-intuitive way of looking at the universe, something that we're not really used to at all.
Now, quantum mechanics at first sight seems like a pretty strange view of the world, but it's experiments like this, the photoelectric effect, done at the turn of the 20th century, that forced us into that picture. Now, this is a gold leaf electroscope, and it's charged up. There's an excess of electrons on this plate, which causes the gold leaf to rise. Now, watch what happens when I turn a light on. The light forces the electrons off the plate, discharging it, and the leaf falls back down again. Now, that's pretty easy to understand. What isn't is that the energy of the electrons that come off the plate depends not on the brightness of the light, but only of the colour. Now, that is impossible to understand if you think of light as a wave motion, and it took Albert Einstein to come up with the correct explanation. He said that you can picture light as a stream of particles called photons, and not as a wave. And the energy of each photon depends only on the colour. That realisation, that explanation of the photoelectric effect, lies at the heart and at the foundation of quantum theory.
Einstein's explanation of the photoelectric effect presented a new challenge to scientists. Up until this time, they had explained the properties of light in terms of waves. Suddenly, it seemed that light could also behave like particles. How could this be?
The resolution to this seeming paradox had to wait for three of the giants of 20th century physics, Feynman, Schwinger and Tominaga. Working independently throughout the 1940s, they discovered a quantum theory of light, quantum electrodynamics, or QED.
Where Einstein had explained the photoelectric effect in terms of particles, Feynman and his contemporaries went even further. With quantum electrodynamics, they provided a mathematical way to explain all the wave behaviour of light in terms of particles. QED was a major milestone in our understanding of nature.